Hey everybody, in this video we are going to talk about the satellite lab for our LUOA curriculum here. So here's our satellite lab. We've got the simulation fired up here. So here we got a little satellite. There's a great video on the lesson showing you how to use the satellite lab. So you can kind of click through these tabs. You can add the ruler, and change the satellite, change the planet, etc. Okay, but how do we actually do the lab portion of it? So if we jump into the lab, let's look at what's going on, kind of give a little brief demo of how we attack the lab. So this lab is all about following the instructions, collecting data, and then trying to make some sort of connection between the data points. So here's how we do that. All right, so we're going to follow these instructions here so we can select the planet. It talks about all these different things here and calculate the circumference of your orbit of your satellite using this formula, etc. Press the start button, time how long it takes for one trip around the planet takes. And then record your data in the data table. And then we want to do some conversions, use the circumference, blah, blah, blah. All right, so steps 1 through 10 tell you how to fill out this table. It's really important that you read the instructions and you follow it directly. So I'm going to give you a demonstration of how one line of this table will be filled out. So to fill out the table, we're going to go over to our simulation. Here's what we're going to do. So we're going to keep the planet the same. So you pick a planet. You can be Earth, it can be Moon, Mars, Jupiter. I'm going to keep it at Earth. I like Earth. It's kind of a nice home to be in. And then what we're going to be doing, so we're going to do that. We're going to throw our ruler up. Go away. And so here we can see our altitude. So we're going to set our altitude. I'm going to set it at 10 million meters. So again, capital M is megameters. That is in millions of meters. So we have 10 million meters right there. And so there's my distance. So that's from the center of the Earth out to Sputnik is my robot. So if I go over to my lab, I can get a couple pieces of information plugged into my table. Okay, so like satellite name, I would type Sputnik. Okay, I can record the mass by going back to my simulation, clicking on my my satellite, and so that's 83 kilograms. So I can go over here, I can type 83 kilograms. The period, we're going to measure that here in a minute. The radius, we can calculate that. That's 10 million meters. So we can go ahead and write that there. And then we can calculate the circumference. And that's something we can calculate here by using the equation right above, right there. So 2 times 3.14 times the radius. Okay, 2.3, so that's about 6.28. So this should end up being 62.8 million meters. I'm doing some quick mental math there. So we'll have to double check that a little bit later. To make sure that number's correct. All right. So, but what we need to do then is measure the values here. Measure the values. And so the main one we're going to measure is the period in minutes. And so if I go back to my simulation, I close my window here. I'm going to go ahead and hide my ruler because I know it's at 10. And I click start. And notice we have minutes are ticking down here in the lower left-hand corner. So I'm going to go ahead and tick that around. I'm going to let that run until it gets all the way around. And I don't want to have any error there, so I just want to let that go. I'm going to let that go and wait for my time here. So it's going to keep going. Play some fun music. Don't worry, I'll speed this up. Maybe. We'll see. We're just going to let it go. 134 minutes. All right, so we're getting ready here. We're going to hit pause in 3, 2, 1. Oh, got it. Yes. Beautiful. All right, so 166.9 minutes. So we go ahead and we put that into our lab. So 166.9 minutes. So I got to convert that into seconds here. So to convert that into seconds, I'm going to multiply that by 60. And I get 10,014 seconds. Okay, and so now you can figure out my speed. So the way you're going to figure out your speed is you're going to take your circumference, the total distance traveled, divided by the time. And we're doing meters per second here. Meters per second. So I take this number divided by that number. Now remember, you do have to convert it from megameters, so it's millions of meters, to meters. So I would put 628.12123 divided by my time in seconds, so 10,014. So that doesn't look very pretty right here, but I can go ahead and calculate that on my calculator. And if I do that, I get 6,271 meters per second. So I'm going to go ahead and delete that. 6,271 meters per second. And I don't know why it didn't do that. Come on. Here we go. Oh, come on. I just want to get this silly word processor. 627.671. And that's meters per second. So I calculated that. That's what I'm doing. I'm going to go ahead and do this. And now here's the change you're going to make. For the part 1, if you read through here, the only thing you're going to change is if you look at number 10, it says we're going to complete the table using each satellite. So now I go back. I'm going to leave the distance the same. I'm going to leave the distance and the circumference are going to be the same. And I'm going to leave the planet the same. I'm not going to change the planet on this. So if I go back to my simulation, all I'm going to change here is change my satellite. I'm just going to go, okay, we're going to do Explorer 1. So it's a smaller satellite. Let's see what happens. So I click here, I hit reset, I go start. Okay, and now I wait. Okay, we twiddle our thumbs. So after you do that, you record your time, do your calculations, do the next one. Go to the satellite, change the satellite. Okay, the Mercury capsule, it's a little heavier. Let's see what happens. There it goes. It's flying around the Earth. Okay, we measured it. We start over. Do the next one. Do the shuttle. Start. There it goes. It's flying around. Okay. And so that's what we're going to do. We're going to repeat that over and over again for each satellite. Okay. So that will fill out this chart. So now that we have this chart, now we're going to make some graphs. Graphs are going to allow us to see a pattern between two pieces. So here we're going to graph the period versus the mass. The period versus the mass. So again, remember, we're typing the name of our satellite. Here's the mass of each satellite. Our period is going to be, we're probably going to take, you can take the seconds or the minutes, but you need to be consistent. So if you're going to do minutes, do minutes. If you're going to do seconds, do seconds. So you're going to make that graph. And then you're going to do a speed versus mass. So then you're going to take this meters per second versus mass. Make a graph. You can use Desmos. You can use the graphing tool that's given in the lab. Either of those work. Okay. And then they're going to ask you to state the relationship. So what's do you observe? Okay. Is it linear? Is it exponential? Does it change by a quadratic or something like a square term? What is the pattern you see? Do they look the same? Is one inverse? So you're just looking for a comparison. What relationship do you see between the graphs? Okay, I believe we're going to do that for graph dependent. So like, what's the relationship between speed and mass? What's the relationship between period and mass? So we're going to do them each individually. What's the relationship? Okay, so then we get to orbital radius and speed. So again, so now we're going to click on our planet. We're going to keep it the same. We're going to select the satellite, select a satellite and keep this the same for the entire selection. Now this time we're going to change the radius. So here if we go to our simulation, so for our second step here, all right, so let's just change this here. Let's go to a different planet. Moon's good. Okay, and let's go to our satellite. Shuttle's good. Okay, and so now we go to our ruler. And so now what we're just going to do is we're going to change our altitude. So notice here, by the way, that changed our scale. So you do need to be careful what you measure it in based on your planet. So here we're in kilometers. So maybe I start at 2,000 kilometers, and then I go up to 2,500 kilometers. I go up to 3,000 kilometers, etc. Oh, notice it jumped to megameters. Watch your units. And then I'm going to make a chart again. So here I'm going to orbital radius. I'm going to calculate the circumference. I'm going to measure the period, and I'm going to calculate the speed. And then guess what? We're making some more charts. Okay, we're looking for the relationship. Then we're going to do planet moon radius speed. So we're going to do the same thing with a different planet, see what happens. Again, it's a lot of collecting data, creating charts. That's what you're going to do through this lab. And that's what a lot of science is. It's a lot of data collection, it's a lot of analysis of the data and making connections to the relationships. Okay? And then we're going to get to parts 5 and 6. We're going to answer some more questions there. You're going to look at Kepler's third law of satellite motion. If you're not sure what that is, you need to go back to the lesson, look up Kepler's third law. And you're then going to look at these values here and make another chart. Okay, again, you're going to graph the result in the resulting equation below using the graphing tool. So again, a lot of collecting data, creating graphs. So I hope this helps you better understand how to approach the satellite lab. And I hope you have a good evening. With that said, have a great night.